Okay, today we are going to talk about the block elements, which is also called the transition elements. And these transition elements are not found abundant in the earth. They are called rare elements. So syllabus say the syllabus which is reduced according to the new pattern. I'll share the screen. The reduced syllabus of class 12 according to the latest council syllabus is the block elements the parts in what are the syllabus which are reduced from in the block elements. So in D and F block elements, some of the topics which are reduced are some important compounds of transition elements, chemical reactivity and lanthanoid contraction and its consequences, general characteristics and comparison of actinoids and lanthanoids. So we are not going to discuss this again because it is not a part of your syllabus anymore. So let us continue with the topic transition elements. So I'm going to share the screen. Let us start the class. Pay attention when the class is going on so that you can answer the question when questions are asked. So I hope all of you did the home assignment regarding noble gases. Okay. So today we'll start with a new topic, a new chapter. The name of the chapter is called D and F block elements. This is the first lecture, and this is uh, the name of the chapter is called D and F block elements. So periodic table, the modern periodic table is classified into three classes. What are the three classes in the modern periodic table? The first is the main, that is also called the representative elements. Representative elements hairgadi apoina kana kana bukhongai hairkanda S block and then P block. P block sida apoina group 13 dagi group 17, mainly group 13 to 17 along with the alkali and the alkaline earth metals. These are called main class of the modern periodic table. Then second we have transition. Transition elements, this belongs in the group 2, okay, group 2 to group 12, starting from scandium group to zinc. Scandium, titanium, vanadium, chromium, manganese, iron, cobalt, nickel, copper and zinc. They will be the first row in the transition series. Then you have the second, third, fourth, fifth. Then next we have the rare earth elements. The rare earth elements are your lanthanides and the actinides. Because of different properties in this row, we have lanthanide series and actinide series. Lanthanide series starts from cerium and goes up to lutetium. Actinide series starts from thorium and goes up to lawrencium. So we have discussed S block elements in class 11, then some part of P block elements in class 11, which is group 13 and group 14. Group 15, nitrogen family, nicomides. Group 16, chalcogen, which is also called oxygen family or forming chalcogens. Group 17, halogens. Group 18, noble gases. We have learned all these in the previous classes. We have learned their properties, we have learned their preparations, we have learned important compounds, and we have learned their uses. So some of the important points you have to keep in mind. I'm going to give you some more important points regarding P block. The thing which you have to focus is ammonia preparation by Haber's process. Nitrogen ki family. Phosphine is already taken out from the syllabus. You don't have to read again. Then in oxygen family, important compound is sulfuric acid by contact process. Preparation of sulfuric acid by contact process is very, very important. Then another point which you have to keep in mind is regarding the reactivity in the halogen family. And xenon oxygen compound is taken out from the syllabus, noble gases. So read those important points. Don't forget to revise again and again what we have learned in the previous classes. So the D block elements, D block elements and F block elements. So together we have this F block elements, lanthanide and actinide series. Okay. So Coming to the first element, which is also called the first row in the transition element, that is starting from scandium. Scandium ki rows mein learn by heart their atomic numbers, get familiar with their names. Okay, I have given you this modern periodic table. You try to remember these names. Okay, starting from scandium up to zinc. So you have to learn by heart the atomic numbers. You have to learn by heart their electronic configuration. How you have to write the electronic configuration. You have to use above principle: scandium, titanium, vanadium, chromium, manganese, iron, cobalt, nickel, copper, and zinc. And one thing you have to keep in mind: chromium and copper, they have their electronic configuration. They have different electronic configuration. For example, in chromium, you will find that the configuration is not 3, it is not 4s2 3d4, but it is 4s1 3d5, because half fill is more preferred and it is more stable than for copper. Also, you will find in the same manner, you will not find 4s2 3d9, you will find 4s1 3d10, because obtaining a stable configuration is preferred. So all of you try to remember these names: scandium, titanium, vanadium, chromium, manganese, iron, cobalt, nickel, copper, zinc. So let us do some electronic configuration for the first series. Okay, scandium, titanium, vanadium, chromium, manganese, iron, cobalt, nickel, copper, and zinc. So before coming to the explanation, electronic configurations, it is very important that you should be able to learn by heart. Okay, you should be able to learn by heart all these element names, learn by heart the names of the elements, and also learn how to write the electronic configuration. So I'm going to ask Hiroda, what will be the electronic configuration of scandium? Hiro, what is the electronic configuration of scandium?
1s2, 2s2, 2p6, 3s2, 3p6, 4s2, 3d1.
3d1. I can shorten the electronic configuration with argon. Argon gisi kya lagre? Argon gidi lagre. Electronic number, the atomic number is 21. So I can write the configuration as argon. Then, the 4s lakadra, 3d lakadra.
Sir, 4s.
4s, 2, and how many d orbitals in the principal quantum number 3? 3d kya lakadra ba?
1.
You keep on telling me for scandium, titanium, right? What is the atomic number of titanium?
22. Argon.
Yes. Argon.
Okay.
Argon.
4s2, 3d2.
4s2, 3d2. Very good. Then what about scandium or titanium? Vanadium, gidi kya atomic number?
23.
23. Very good.
Argon Lenny.
Argon Lenny.
4s2, 3d3.
Very good. 3d3. Indicate me what is the next element?
Chromium.
Chromium. What is the atomic number of chromium? Atomic number of chromium kya
24.
24. Configuration hero argon. Is it section? 4s. 4s electrons kya hoga daba 3d da kya hafta daba hero?
3d5. 4s0.
4s0 bhi ade. 4s0 kita the electrons in one le. Ichu we doing 4s1 hoga daba. Tumbra.
Also.
Argon ki 18 like re. 4s1 19 like re. Sida. Why I am not writing 4s2 3d4? Half fill orbital is stable and is preferred. Agi budong sai. Aduna chromium ki electronic configuration se sida you should be able to write the electronic configuration for chromium. Don't put 4s2. You have to put 4s1 3d5. As I have told you in class 11, electronic configuration in the then copper.
Mm.
What is the atomic number of copper? Yeah, you need to Susanta Hero copper local. What is the atomic number of copper? Copper electronic configuration क्या नो? 29 निको.
Carbon
Carbon
4s1
4s1.
3d10.
Very good. 4s1 3d10. Aduna noina khanggadaba point se kano copper ga chromium gidi mogi electronic configuration sa it has 4s1 3d5 and 3d10. And for us zinc is itopiro. What is the atomic number of zinc? Zinc atomic number zinc is 30. So you will find completely filled in the d orbitals. So we can say zinc has the electronic configuration argon 4s 2 3d 10. So like this, we should be able to write all the electronic configuration as home assignment. Write down all the electronic configuration for transition elements. Okay, write down all the electronic configuration of the transition elements. So I can summarize the general electronic configuration of transition elements. So what will be the general electronic configuration of the transition elements? Can anyone tell me what will be the general electronic configuration? Can you summarize the general electronic configuration of the transition elements? What is the valence cell? Valence cell is always going to be 4 for these elements belonging in the fourth period. So you can say NS2. Then what is the penultimate cell? Penultimate cell actually cell next to the valence cell. Cell second outermost to the valence cell. So this is NS2 and minus 1. D 1 to 10. This is the general electronic configuration of the transition elements. The general electronic configuration of the transition element is NS2 and minus 1 D 1 to 10. Tajira, what is the general electronic configuration of the transition elements?
Sir, N is to N minus 1, D1 to 10.
So all of you try to write the electronic configuration of the entire transition homework. The fourth row, fifth row, and the sixth row. Okay. Then moving on to the next point. I will clear the screen. This is an introduction to the transition elements, which is also called the D block elements. So position in the modern periodic table, let us see. These transition elements start from group number 3 to group number 12. Group number 1 and 2 is S block. Okay. Group number 13 to group number 18 is P block. Marakta laiba block se apoina kai hai transition elements. The name itself says transition because they are flagged between the S block and the P block. Flag like a sandwich. Okay, these D block elements are sandwiched between the S block, which is also called the alkali and the alkaline earth elements, earth metals, and the P block elements. So this transition elements, the name itself says transition because these are flagged between the S and the P block elements. You have learned in detail about S block. You have learned in details about P block in the previous classes. Now we have come to the D block elements, transition between the S and the P block elements. So group number 3 to group number 12 are the transition elements. Okay, they are also called the D orbitals. Why they are called the D orbitals? Because the electrons are progressively filled up, okay, in the D orbitals, which is also called the penultimate cell. In the penultimate cell, the electrons are progressively filled up in the vacant D orbitals. The elements constituting the D block are those in which the D orbitals are filled up incompletely, okay, in the d orbitals, and hence the name d block. And they are also called transition elements because they are flagged in between the s block and the p block. May ideally do it, as you can see in the modern periodic table. And the d block element occupies a very large middle section. In the modern periodic table, the block element occupies a very large region in the modern periodic table. They are flagged in between the S block and the P block. And the name itself says transition. The name itself says transition because it is given the name transition because they are in between S block and P block. And there are how many rows in the D block elements? There are 3D, 4D, and 5D. The fourth row of the 6D is incomplete wave because new cells are being added, electrons are being added, and they are incomplete. And you will find lanthanide and actinide series, okay, later on because their properties are different. So we have kept them in a separate row. So starting from cerium to deuterium, then actinide Q in the lawrencium positive. These two series are going to be called rare earth elements because they are not found abundantly in the Earth's crust. They are called rare earth. Mamangi S ka piduna representative. D block sina transition. F block sina rare earth. Okay, I'm going to show you some of the series. As I have told you, first series, second series, third series, fourth series. First series, the electronic configuration E group. What are the elements which comprises the first series? Let us have a look. The elements which comprises the first series are scandium, titanium, vanadium, chromium, manganese, iron, cobalt, nickel, copper, zinc. Learn by heart. If you learn by heart these elements, it will be very helpful for you, okay, in exam. You should be able to write all the electronic configuration. At least the first series, even if you forgot the second series, it doesn't matter. But the first series is very, very important. Okay, remember the elements in the first series of the transition metals or the D block elements: scandium, titanium, vanadium, chromium, manganese, iron, cobalt, nickel, copper, zinc. After learning the names of these elements, now you have to learn by heart the atomic number. There are 10 elements in each row. Elements first series is second series is because it starts from 3 to how much? 12. So there are all in all 10 elements in these rows. Scandium, titanium, vanadium, chromium, manganese, iron, cobalt, nickel, copper, zinc. After learning by heart the atomic number, you have to write the electronic configuration. Masai, I have asked your friend Kiroda, what is this electronic configuration of scandium? Mana the electronic configuration of scandium is argon 4s2 3d1. Argon 4s2 3d1. Or how many electrons in the 4s orbitals? 2. How many electrons in the d orbitals? 1. Right? Make a table of all the elements in the D block. Okay, as a you are going to get more and more familiar with the elements. Unless you are familiar with the elements, unless you are familiar with the atomic number, it will become very difficult to study these elements. We're going to learn a lot about their oxidation state. We're going to learn a lot about their chemical properties. So it is very important, it is compulsory for you to remember the names as well as learn by heart the atomic number. Then this chapter will become very, very easy for you all. Okay, and learn by heart the general electronic configuration. What is the general electronic configuration of the D block elements?
NS2, N-1,
NS2, N-1, D 1 to 10.
1 to 10.
Now, coming to the next element, titanium. The general configuration is argon 4s2 3d2. And as you can see, all these 4s the electrons are they are all going to be 2. They are all going to be 2, except for whom? Except for the 1 oi hero, mention be hero. Karam element the 4s electrons is 1, as you can see from the table. What are the elements in which the 4s has 1 electrons?
chromium,
Chromium and
copper,
copper. Chromium copper is the electrons say s orbitals among the ko. D the kya half filled and completely filled. Half filled and completely filled, they are very stable. Okay. So there will be excitation of electrons from s to d orbitals. Aduna, nature prefers stability. So electronic excitation will take place and it will obtain the half filled or completely filled. Completely filled nature half filled CD stable wave. Yaraniko, scandium, titanium, vanadium, chromium, manganese, iron, cobalt, nickel, copper, zinc. But by electronic configuration electronic configuration come atomic number iron atomic number 26. Configuration 6 already line the thumb rule is 6 already D6 D6 configuration, D5 configuration and what is the electronic configuration of vanadium? Vanadium atomic number 23 D3 configuration. Vanadium configuration 3D D3 configuration. D orbitals the electron atomic numbers such as Jingi magi electronic configuration Jingda electrons in the d orbitals Jingi atomic number sat down Jingi the Aroibi element in 30 3d10 completely fill away stable over Kanguni. Iron the 26 6 orbitals in the d, so 6 electrons in the d orbitals. So smile pagadavani aduna in higher point learn by heart these elements. Okay, the first row, the first series in the transition metals. Then coming back to the second series, the introduction in the we are going to do some introduction for the block elements. Second series the elements in the second series starts from yttrium. Why na the name of this second series is called yttrium. Zirconium, yttrium, zirconium, niobium, molybdenum. Okay, then technetium, ruthenium, rhodium, palladium, silver, and cadmium. So try to remember again the second series. First series, process learn by heart the names of the second series. We have learned by heart the first series: scandium, titanium, vanadium, chromium, manganese, iron, cobalt, nickel, copper, zinc. Similarly, let us come again to the second series. What are the elements present in the second series? These are yttrium, zirconium, niobium, molybdenum, technetium, ruthenium, rhodium, palladium, silver, and cadmium. So before coming to second series, there are many important characteristics of the block elements. The block elements say drugs, catalyst. Can anyone tell me one important catalyst? Okay, in the first series, catalyst elements. Susanta Hero, what? Name one catalyst in the first series using these metals.
Potassium dichromate.
Anyone?
Nickel.
Nickel. Okay, what is the name of the nickel? Nickel na siyang catalyst maming to kay Kowi. Nickel catalyst. Have you heard about Rane nickel? Rane nickel se koi organic chemistry discussion ko. Then sulfuric acid se ando matamda catalyst amakak sinagi. Can you tell me the name of that catalyst used in contact process? Susanta. Vanadium na siyang catalyst Kowi. Vanadium na siyang give catalyst to. Akang bayaw gadi mi ko sa tayo.
Vanadium.
Vanadium.
Like the devil ko tanaw mana kanagadi adum hiro. Can anyone tell me the name of the catalyst from vanadium?
Vanadium pentoxide.
Yes, kaya no? V2
Vanadium pentoxide.
divanadium pentoxide. Okay, chromium is same chromium oxide, manganese dioxide, iron is same iron oxide, Haber's processes in icon. So most of these transition elements, they are able to form catalysts. Okay, and is there anyone who knows the name of that anti-cancer drug? The first anti-cancer drug. What is the name of the first anti-cancer drug? Name of the first anti-cancer drug. This is general science. The block elements lecturing the points I hope see. The Jira Hayakera, Keroda Hayakera, Tej Hayakishwai, Janet. What is the name of that anti-cancer drug first discovered? Susanta Hagadra. Hagadra. The name of that anti-cancer drug is called cisplatin. Okay, cisplatin. Annotation, don't write on the screen. The name of the drug is called cisplatin. So, see transition elements ki kana ba mayam laye ko. Second series the negative elements in kana no yingsi yttrium, zirconium, niobium, molybdenum, technetium, ruthenium, rhodium, palladium, silver, and cadmium. Palladium is also one of the important catalysts. Okay, and you can make many more drugs using these complexes. Iron as monomeric iron. Then coming to the next series is the third series. Third series, the third and fourth series, they are going to be placed in the F block. The third and the fourth series, they are going to be placed in the F block because of different properties. Say these elements from lanthanum, okay? Lanthanum, hafnium, tantalum, tungsten, ruthenium, osmium, iridium, platinum. So I give the platinum is a transition element. Platinum, cisplatin, gold, and mercury. So since electrons are filled up in the outermost cells, 6s, they will belong in the 6th period. The fourth series 7s. Remember this atomic number and you can easily write the electronic configuration. But you will find that there is some jump, quantum jump from lanthanum to hafnium. Look carefully. The atomic number is not in a regular manner. 57 50 there is some missing elements. Why these elements are kept separately? These elements are gradually filled up in the F orbitals and they are belonging in the F block. They have different properties. Okay, so they are placed in a different row, namely the lanthanides and the actinides. So what are the lanthanides and actinides? We'll see tomorrow. For today, let us see the electronic configuration of the D block elements. The general electronic configuration of the D block elements it is n-1, D 1 to 10, okay, then ns 1 to 2. What is this ns? This is the principal quantum number. Outermost principal quantum number is the valence shell. Outermost principal quantum number n is the valence shell. Then n-1, this is the penultimate shell. D orbitals in the name. So general electronic configuration is n-1, D 1 to 10, ns 1 to 2. Now, because of very little energy difference between n-1 ga ns, energy difference because of this less energy difference between the n-1 and ns. In case of chromium, it is 3d5 for s1 instead of 3d4 for s2. As I give anomaly anido. Chromium go copper sa moi energy difference yam khenadreba. Aduna moi di stable over pambanina half fill natraga completely fill cd. Nature na pami. It is more stable. Half fill or completely fill is more desirable, which is having more stability. Therefore, they will have n-1 D or ns2 ns 1 to 2 electronic configuration. So try to remember this electronic configuration. Don't forget. Then the next point I'm going to tell you is zinc, cadmium, and mercury of group 12 have full D10 configuration. Okay, zinc, cadmium, and mercury. they belong in the same group. Zinc haibasina karamba series ta 3D series ta. Mercury sina karamba da 4D da. Okay. Zinc, cadmium na 4D, mercury na 5D da. So zinc, cadmium and mercury, they belong in the which series? 4th series, 5th series and 6th series. And this electronic configuration is completely filled. D10 configuration in their ground state, uncombined state, as well as in their common oxidation states, they are not regarded as transition metals. Transition metals in a zinc, cadmium, mercury, they regard because by the definition of transition metals have those elements in which the d orbitals are incompletely filled. Definition of transition elements are the metals in which the electrons in the d orbitals are incompletely filled. So zinc, cadmium, and mercury. Wow, zinc, cadmium, and mercury, they belong in the group 12, and they have completely D10 configuration. D10 ground state. They are no longer regarded as the transition elements. Transition elements power. Why they are not regarded as the transition elements? Because they have completely failed. They have completely failed d orbitals. Completely filled d orbitals the my transition elements की definition to chandre or obey to and hence they are not regarded as transition elements. Transition elements ko zinc, cadmium, and mercury. However, being the n members of the three transition series, their chemistry is studied along with the chemistry of transition elements. Mogi elements sina aroi ba oibunina. Okay, their electronic configuration is at the end, and since they are not regarded anymore as transition elements, we're still going to study the chemistry of these elements, namely zinc, cadmium, and mercury. Zinc, cadmium, and mercury, they have completely filled the orbitals. The transition elements, since they are at the end of the members, we are going to study their chemistry. And there's a question I want to ask you. On what ground can you say that scandium is a transition element but zinc is not? Because again, I give a point though. Answer to Vidya Lakshmi hero. Transition elements or high target mass completely fill or you should not have completely filled electrons in the d orbitals. So can you answer this question? On what ground can you
Scandium.
Yes, the question.
Scandium dadi mado jimagi d orbital do completely fill oidebako aduga zinc dadi completely fill oy.
Transition elements we high target penultimate cell vacant the orbitals to fill up. It should have incomplete. Okay, very good. Then silver has completely filled the orbitals, that is 4d10 in its group. How can you say that it is a transition element? So is there anyone who knows the answer? You can unmute yourself and tell me the answer. This is just a logical concept, Nicole. If you have the answer, you tell me. Why silver has completely failed? Look at the second question and tell me. Is there anyone who knows the answer? Those who know the answer can tell me. This question is application type question. Silver atom, okay, has completely filled 4d10 configuration. Madi fifth period belong to the element. So silver ki magi ion se. What is the how many electrons you are going to remove from silver ion? You are going to remove 2 electron. Electron ani lothok doine. So when you remove this 2 electrons, magi configuration se ahan budadi kya lerami. What is the configuration of silver ion? You are going to remove these electrons. Okay. So when you remove these electrons from the silver ion, the configuration will now become electron ani mang gi matam ma 4s1 3d 10 ni ko configuration se akoina electron mang gi matam di kala ani you have 4d9. 4d9 is the configuration. Okay, silver ion is a transition element type. But one more important point you have to remember, there are many precious metals such as gold, silver, they are called noble metals. Okay, these noble metals, they are very precious. Okay, and unlike other elements, these various precious metals such as silver, gold, and platinum, they are industrially important. And industrially important metals, along with iron, copper, and titanium, they also form a part of the transition metals. So these elements, noble metals, they form an important part of transition metals. We're going to see their chemistry later on, how they react with one another. And then some of the general properties of the transition metals which you have to keep in mind. Number one, metallic properties such as high tensile strength. So can anyone tell me what is the meaning of tensile? Again, what is the meaning of tensile? Tensile hai keno kero dayo. Ductile hai bisine keno, tensile hai bisine keno.
Sir, ductile hardi yamna line kani keno gumba wire gumba da kon ba yabo sir.
One sang na copper wire
Oh, sa support
electric wire. Malleability have been keno.
Malleability hargana sir kano gumba se gold gumba se yamna pana ithok ke yethok pa yaba se sit oina plain sit yamna pana
magi elasticity yang wang ko. Okay. Then electrical conductivity laini, high thermal value laini, adagi shiny character laini, gold, silver, platinum, mo gesi am lange, machu jam khajai ko. These are the important characters which we are going to study. Metals natani mo ko. They are very hard and good metals. Transition elements are mostly metals. And then point number 2, the transition metals with the exception of zinc, cadmium, and mercury. Moigidi completely fill with gramnina point. They are no longer regarded as transition elements. Okay, and these transition metals, except for zinc, cadmium, and mercury, they are very hard and have very low volatile. That means they cannot be easily melted. Okay, my melting point yang wang and they have very high melting point. And the d orbitals, they have periphery of an atom more than the other orbitals and exhibit characteristics property. So paikada hangdoin in my council exam sige point kar issue ko. Name some characteristic properties of d block elements. Ahan bada variable oxidation state. Ai sige parasil oi matam da coordination compounds ta khini ko. Coordination compounds tamo matam da metal ga ligand gi marakta labor relationship tuni. Most of the central metal atoms, they will be from the transition elements. They will not be from the P block, they will not be from the S block, but most of them will be from the D block. And they form different types of compounds named coordination compounds. Metal ga ligand gi marakta labor relationship tuni hoin coordination chemistry terms. Aduna variable oxidation state label ng misikeno d orbital sida magi oxidation state sa it ranges from 1 to 10. Aduna electron excitation, electron de-excitation to begin mapanggan su yang kangkalakani covalency su yang wangakani ko. Covalency wangagadi moina same gadaba compounds makan thola ani ba. So variable oxidation state layakani. Point number 2, the formation of colored compounds. D orbitals sida akoina orbitals mga kakaidoi under the dxy, dyz, dzx, dx square minus y square, dz square. High orbitals sa group ani thona kaidoi kani ba. T2G haibama, EG haibama. EG sina atopa separate orbitals ani, T2G sina kona makadulani. Aduga electrons sina chongthok chongjin tawbo ngamdoi ne ba. from one orbital of D to another orbital of D. Set any thona khaidorkani ko. So when this electronic excitation take place, class 12 ki chemistry the kaitamgi structure of atoms. When electronic excitation takes place, there will be coloration of compounds. Color people ngam. Point number C, the hiding is complex formation. Complex में हम सेम को दोने coordination complex है ना को देखिए catalytic property अपने हैं तमसी that paramagnetic behavior catalytic property दा कोई catalysis होने एक तो बुंगा में है कि खुदा मोइन example होने अपर पीर बुदा divanadium pentoxide को देखिए manganese dioxide, iron oxide, chromium oxide, copper chloride, many of them they form catalysts, so they have the ability to form catalysts. Then point number 5, unpaired electrons lergadi magnet chingsan bangam sigi phenomenon sibu koina kayana kangnai. We call this phenomenon, what do you call this phenomenon? Paramagnetism. Unpaired electron latragadi magi dipole moment cha handarani aduna sigi properties na kay kangnai. We call this properties dimagnetism. So hayang amu continue to siko sigi matang da aduga magnetic behavior matang da koi unit expression which is also called dipole moment. How to find the dipole moment? You are going to use this relation mu equals to root over n plus 1, and this unit is going to be in Bohr magneton. So number of unpaired electrons is doctor asana d orbitals the first series we have iron ki magi atomic number se kya iron ki atomic number is 26 ni ko 26 is the magi d the electron masing kya 6 never yarba argon 4s2 3d6 natro adu taragadi 3d6 sida half fill se kya lai mari layer maniba chumbra amadi pair oigrani mari sina half fill oirni sigi half fill sina 4 oigiba matamda we can easily find the magnetic moment for iron. Aduna simply substitute 4 plus 1 the 5 taramani aduna my Bohr magneton se kya tara root over 20 Bohr magneton root over 20 the kya gi chang de lakani 4.3 something the lani ko Bohr magneton se so sumaina half fill leba kangu dati magi unpaired electron yang wangani unpaired electron masing yamgani aduga magi paramagnetic character so kai wangamani half fill dati agino hayagadi unpaired electron masing yame aduna electrons sigi magi half fill si yamagadi magnet chingsan bagi tendency su wangani. So we are going to study this again in details. Ahan bada magi introduction ni ko ngasi takri sa ngasi ke kita kage kara summarize to kero da.
Sir, the block elements ki mam da khara high grade sir. The block elements yaw do se group number 3 da ke horga group number 12 ho. Aduga mogi general electronic configuration je ns1 to 2 to n-1 d 1 to 10.
Yes. Tell me the elements of the first series. Ahan bada scandium degi horo.
Scandium, titanium, vanadium, chromium, manganese, iron, cobalt, nickel, copper, zinc.
Very good. Iron, cobalt, nickel, copper, zinc. What are the elements which have exceptional electronic configuration?
Sir, chromium ga copper ga.
Tell me the electronic configuration of chromium.
Sir, argon gi legani adu lorkanda 4s1 3d5.
And the Vijayalakshmi, what is the general electronic configuration of this transition elements?
ns2 n-1 d to the power 1 to 10.
Very good. Usman no my time hero. Lotion bhi arabo sir. Okay. Ngasi gi diswai the lotion la se hayeng amu continue to si ko home assignment. Okay. Thank you for joining the class.